I'm going to show you how to do problem number 57 from your homework. We start off with the function capital H of x equals the integral from 0 to x of f of t dt, where f is a continuous function with the domain 0 to 12 graphed here. So this graph, this blue curve, is y equals f of x. So f of t is this function here, the blue graph. Capital H of x is another function where h of x is the integral from 0 to x of the function f of t dt. So what that means, and it's really important that you understand what it means, when I say I want h of 2, for example, if I said what's h of 2, h of 2 is the integral from 0 to 2 of f of t dt. So what is h of 2? Well, h of 2 is going to be the area under this curve f of t from 0 to 2. It would be the area of the red region there. All right, and if I said h of 4, then it would be now this area, the red. And if I said h of 6, it would be all of this area. So you can see as x is getting bigger, the function h of x is increasing because there's more area. Now, if we go past that, you need to understand that if I said, let's say I wanted h of 8, which is the integral from 0 to 8, now I continue on and I've got this area that's now down below. So now we're going to be subtracting off this area, and so h of x will be decreasing. The function h of x will be decreasing. And of course I can continue that on, that same idea. H of 10 would be the area that I have up here, subtracting off the area down here. And of course h of 12 would complete all of this, and that would again be all the area up here, subtract all the area down here, would be the value of h of 12. So now that we understand that, let's answer these questions and see if we can understand how we're supposed to answer these questions. The first one, definitely the easiest one, find h of 0. So for A, h of 0 is simply the integral from 0 to 0 of f of t dt, and of course, that's just 0. All right. Now for B, it says on what interval is h increasing? So the way you need to think about this is quite simple. Don't get intimidated by the graph and all that stuff. Just ask yourself the question that you already know the answer to. When is any function increasing? A function, h, is increasing when h prime is greater than 0, right? So, when is h prime greater than 0? And what is h prime? Well, h prime of x is equal to f of x. And that's from the fundamental theorem of calculus part 1. We know that when you take the derivative of an integral with a constant lower bound to a variable upper bound, all we have to do is plug in that variable upper bound into the integrand. So the derivative h prime of x equals f of x. Hopefully that's very easy for you now at this point, and you understand that. So since h prime of x equals f of x, what am I looking for? I want to know when h prime is increasing. I want to know when h prime is greater than 0, which means since h prime equals f, I want to know when f is greater than 0. So we can easily see from the graph that the function f is greater than 0 right here from 0 to 6. So my answer to question B is h is increasing from the interval 0 to 6 because h prime of x, which equals f of x, is greater than 0. And I'm writing all this that way because as you progress forward in this course and for the AP test, they're pretty much always going to ask you to justify. And so I'm going to go ahead and do it that way now, and so you can learn that you should be doing that as well. And of course, that's what they said when they ask explain or justify. So part C says, on what interval is the graph of h concave up? The graph of h concave up. So it's the function h again. And then once again, we know that it's concave up when h double prime is greater than 0. So I want to find where h double prime of x is greater than 0. But we know that h double prime of x, since we know that h prime of x is equal to f of x, that would mean that h double prime of x would equal f prime of x. So h double prime of x equals f prime of x. So now I need to figure out where f prime of x is greater than 0. Now f prime of x, of course, our function f is right here. And the derivative, of course, is the slope of it. And if I want to know when f prime is positive, I need to have a positive slope. And that's going to happen from here at 9 to 12. From 9 to 12, the slope of f is positive. And so I will answer that h is concave up on the interval from 9 to 12. And that's because h double prime of x, which equals f prime of x, is greater than 0. And I do want to add, I might not have said it before, well, you can't just say, on the AP test, you can't just say it's because h double prime is greater than 0. You have to make a connection between h double prime and f prime of x. And if you don't do that, you won't get credit. So be aware of that right now. All right, part D. Is h of 12 positive or negative? Well, h of 12 is going to be, again, as we talked before, it's this area subtract the blue area. The red area subtract the blue area. Well, there's more area above than there is below the x-axis. So h of 12 is positive. And next we go to, and that's a good one because there's more area above than below. Where does h achieve its maximum value? Now, this throws a lot of students for a loop here because they're saying, where's it a max? I mean, they're starting to look at, when I first started, I used to look at the areas and say, okay, well, the area's getting bigger and bigger and bigger, and then it starts getting smaller and smaller and smaller, so the max must occur at 6, but that's not a very good reason. And it's true, though, but what you want to do on the AP test and the way your brain needs to think is the same way we thought before. We have a function, h. We want to know where its maximum value is. Well, we know maximum value occurs when what? When the first derivative changes from positive to negative. And you could also use a second derivative test, but I think it's simpler to use the first. So h achieves its maximum value, or a maximum value, a relative max, when h prime changes from positive to negative. Now, because it says where does h achieve its maximum value, they actually mean the absolute max. Okay, so let's go ahead and answer the question. For part E, h achieves its absolute maximum value at x equals 6. And that's because h prime of x, and then again, tie that into f of x, changes from positive to negative. All right? So that takes care of E. Let's do one final question. Where does h achieve its minimum value? And of course, h will achieve a minimum, whether it's max or not, when h prime, which equals f of x, changes from negative to positive. Well, when you look at this graph, it never changes from negative to positive. So what does that mean we do? Well, you need to look back at the very beginning of the problem. It's a closed interval from 0 to 12, so that means we have endpoints. So because we have endpoints, left and right endpoints, maybe there's a minimum value there. So let's take a look. The left endpoint is at 0, 8. So h prime, remember, equals f of x. So h prime is positive at the left endpoint and immediately after the left endpoint. So that means that if a function, in this case h, has a derivative that's positive immediately after the left endpoint, that means the function h is increasing and the left endpoint has to be a min. Let's also examine the right endpoint. The right endpoint, immediately before the right endpoint, h is going to be negative, which means h has to be decreasing down to the right endpoint. All right, if h prime is negative. And so that means that that's also a minimum. So we have minimums at both places. So where does h achieve its absolute minimum value? Well, h will achieve its absolute minimum value at x equals 0. And that's because h of 0 equals 0, because the integral from 0 to 0 is 0, and h of x is going to be greater than 0 for all x values from 0 to 12, not including 0. So once you go past 0, you're getting a positive area here, and because this area below is never going to achieve more than what was above, h of x will be greater than 0 all the way through, so that means it's going to be, any value is going to be bigger than h of 0, which is 0. So the absolute min will be at x equals 0. There is a minimum value at x equals 12, but it's a relative min. It's not the absolute min.